Today's session is about Jacobian. A Jacobian matrix is a matrix that can be of any form and contains a first-order partial derivative for a vector function. It can be square matrices or rectangular matrices. The main use of Jacobian is found in the transformation of coordinates. Jacobians are used in the study of transformations, optimization, and differential equations. Let's understand it clearly. If u and v are functions of two independent variable x and y, then this determinant is called Jacobian of u and v with respect to x and y. Jacobian is denoted by delta uv by delta xy. It's also written as j of uv by xy. Similarly, Jacobian of uv and w with respect to x, y and z is delta uv w by delta xy z is this determinant. Properties of Jacobians. 1. If uv are functions of xy and xy are functions of uv, then j dash is equal to 1. Delta uv by delta xy times delta xy by delta uv is equal to 1. 2. If uv are functions of rs and rs are functions of xy, then delta uv by delta xy is equal to delta uv by delta rs times delta rs by delta xy. 3. If function uv of three independent variables x, y, z are dependent, then delta uv by delta x, y, z is equal to 0. Let's understand it clearly with an example. Example 1. If u is equal to x plus 3y square minus z cube, v is equal to 4x square yz, and w is equal to 2z square minus xy, then find delta uv by delta xyz at 1, minus 1, 0. Solution. Given this, delta uv by delta xyz is equal to determinant this. Delta u by delta x is differentiation of u with respect to x, so here other two terms y and z will be constant, hence 0. Differentiation of x is 1. Similarly for delta u by delta y, differentiation of 3y square will be 6y and x and z terms are 0 as it is constant. Delta u by delta z is minus 3z square. Other two terms are constant, hence 0. Now delta v by delta x, differentiation of 4x square, is 8xy and z are constant, here multiplicative constant, so we get 8xyz. Delta v by delta y is differentiation of y is 1, 4x square and z are multiplicative constant, hence we get 4x square z. Delta v by delta z is differentiation of z is 1 and 4x square and y are multiplicative constant, we get 4x square y. Now, delta w by delta x, this term will become 0 as z is constant, differentiating this, is minus 1. Y, and y constant, here multiplicative constant, we get y, delta w by delta y is, this term will become 0 as z is constant, differentiating this, is minus 1. X, and x constant, here multiplicative constant, we get x, delta w by delta z, differentiating to z square is 4z and these two are constant, hence 0, we get this. Now substituting the values 1, minus 1 and 0, we get this. Finding determinant is equal to 1 times 0 minus 4 is minus 4, minus 6 times 0 minus of 4 is 24 plus 0 times minus 1 is 0, simplifying we get 20. Example 2. If x is equal to r cos theta and y is equal to r sin theta, then find delta xy by delta r theta and delta r theta by delta xy. Solution. Given x is equal to r cos theta equation 1. Y is equal to r sin theta equation 2. Jacobian of x and y with respect to r and theta. Delta xy by delta r theta is equal to this determinant. Now, delta x by delta r is differentiation this, r cos theta, as we are differentiating with respect to r, differentiation of r is 1 and theta is constant, hence constant multiplication rule, we get cos theta. Delta x by delta theta is differentiation this, our cos theta, as now we are differentiating with respect to theta. Differentiation of cos theta is minus sin theta and r is constant. Hence constant multiplication rule, we get minus r sin theta. Delta y by delta r is differentiation this, r sin theta, as we are differentiating with respect to r. Differentiation of r is 1 and theta is constant. Hence constant multiplication rule, we get sin theta. Delta y by delta theta is differentiation this, r sin theta, as now we are differentiating with respect to theta. Differentiation of sin theta is cos theta and r is constant. Hence constant multiplication rule, we get r cos theta. We get this. Find the determinant of this, difference of product of diagonal elements. R cos theta times cos theta minus of r sin theta times sin theta, taking our common cos square theta plus sin square theta is 1, hence we get r. B. To find delta r theta by delta xy, we have to partially differentiate it with respect to x and y, so need to convert in terms of r and theta. To convert it in terms of r, square and at equation 1 and 2, simplifying we get this. To convert it in terms of theta, divided to by 1, we get this. Simplifying, we get theta is equal to tan inverse y by x. Now, delta r by delta x is differentiating this with respect to x. X square will become to x and y square is 0 as y is considered as constant while differentiating with respect of x is equal to r square becomes to r. Delta r by delta x is equal to x by r. Delta r by delta y is differentiating this with respect to y. Y square will become to x and x square is 0 as x is considered as constant while differentiating with respect of y is equal to r square becomes to r. Delta r by delta y is equal to y by r. Now, delta theta by delta x is differentiating this with respect to x. Delta tan inverse y by x is a composite function. Hence chain rule is used to differentiate it. Differentiating outer function tan inverse is 1 by 1 plus y by x whole square. As we know tan inverse x is equal to 1 by 1 plus x square. Now differentiating in a function y by x, we get minus 1 by x square. Y is constant. Constant multiplication rule, we get y times minus 1 by x square. That is taking LCM and simplifying we get y by x square plus y square. X square plus y square is equal to r square. Thus we get minus y by r square. Delta theta by delta y is differentiating this with respect to y. Delta tan inverse y by x is a composite function. Hence chain rule is used to differentiate it. Differentiating outer function tan inverse is 1 by 1 plus y by x whole square. As we know tan inverse x is equal to 1 by 1 plus x square. Now differentiating in a function y by x, we get 1 as differentiation of y is 1 by x, because x is constant. Constant multiplication rule, we get 1 by x times 1. Taking LCM and simplifying we get x by x square plus y square. X square plus y square is equal to r square. Thus we get x by r square. Substituting the values, we get this. Determinant of this is x by r times x by r square minus y by r times minus r square. Simplifying we get 1 by r. To verify jj is equal to 1. Substitute the values and simplify, we get 1. Hence proved. Example 3. If x is equal to ux, y is equal to u plus v by uv, find delta uv by delta xy. Solution: delta xy by delta uv is equal to determinant of this. Delta x by delta u, this is x, differentiating we get v. Delta x by delta v, differentiating we get u. Delta y by delta u, y is this, differentiate by quotient rule, we get this. Delta y by delta v, differentiate by quotient rule, we get this. Find the value of determinant. v times 2u divided by u minus v whole square, minus u times minus of 2v divided by u minus v whole square. Simplifying, we get 4uv by u minus v whole square. By Jacobian property, J dash is equal to 1, this into this is 1. Substituting the value of delta xy by delta uv, obtained above here, simplifying and rearranging, we get the required value of delta uv by delta, this. Example 4, find the value of the delta uv by delta r theta, when u is equal to x square minus y square, and v is equal to 2xy, and x is equal to r cos theta and y is equal to r sin theta. Solution. Let's understand the question first. Here we have to find out the value of delta uv by delta r theta. U and v are given here, but value of r and theta are not given, but it is given as function of x and y. So, in such questions, Jacobian property is used to solve. Given x is equal to r cos theta equation 1. Y is equal to r sin theta equation 2. Square and add equations 1 and 2. We get x square plus y square is equal to r square. We will be using this Jacobian property. If u v are functions of xy and xy are functions of r theta, then delta uv by delta r theta is equal to delta uv by delta xy times delta xy by delta r theta. Delta uv by delta xy is equal to this determinant. Now, find the value of this determinant. Delta u by delta x, that is differentiate with respect to x, this is u. We get to x as y is constant. Delta u by delta y, differentiate with respect to y, we get to y x being constant. Delta v by delta x, this is v. Differentiating, we get to y, and delta v by delta y is to x. Finding the determinant, difference of product of diagonal elements, we get 4r square. Delta xy by delta r theta is equal to this determinant, finding the value of it. Delta x by delta r is equal to cos theta, as theta is constant. Delta x by delta theta is equal to minus r sin theta. Delta y by delta r is equal to sin theta. Delta y by delta theta is equal to r cos theta. Now, find the product of the elements in the diagonals and find its difference, we get r. By the property this is equal to product of these two, substituting the values 4r square and r, we get r 4 cube. Example 5. If u is this and v is this, show that u and v are functionally dependent and find the functional relationship. Solution. For u and v to be functional dependent, delta uv by delta xy needs to be 0. Let's solve. Delta uv by delta xy is this determinant, delta u by delta x is, u is this, differentiating with respect to x, differentiating x is 1 and y term remains, as y is constant and constant multiplication rule. Root can be written as to the power 1 by 2 plus differentiation of this, y constant multiplication rule, differentiation of under the root 1 minus x square is 1 by 2 times the inner function to the power 1 by 2 minus 1, which is minus 1 by 2 into differentiation of inner function, which is minus 2x. Simplifying, we get this. Delta u by delta y is differentiating this with respect to y, we get this. Delta v by delta x is differentiating this with respect to x, we get this. Delta v by delta y is differentiating this with respect to y, we get this. Substituting the values, we get this. Finding the determinant value, difference of products of diagonals. This. Simplifying, we get 0, hence, u and v are functionally dependent. Relationship between u and v. V is this, let sine inverse x is a and sine inverse y is b. Then v is equal to a plus b. Multiplying both side by sine. Sine v is equal to sine a plus b. Is equal to sine a. Cos b plus cos a sin b. Is equal to substituting the value of a and b, we get this. Simplifying. U is equal to sine v.